In 2022, students had an option of picking 3 out of the 4 Part B questions. And for some reason, this question, which is it's on sequences and series basically, but it's also on logs and indices, was least picked out of all of them. Maybe question 10 was also very unpopular as well, but for some reason this one, people were turned off by this one, even though you'll see in a second there was a lot of marks that were picked up in it, easy marks picked up in it. Like, you should be aiming at minimum to be getting 30 out of 50 in these Part B questions, and it was very easy to pick up 30 marks in this. Right, so if you look at the background to it, it's about when a certain drug is taken, how much, as time goes on, how much does the drug deteriorate in your body. Right, and the very first question is very simple: how much drug is left after 2.5 days, which is just simply substituting 2.5 into the formula, and it comes out as 4.18. Very simple 5-mark question to start. And the Part B then is the opposite, right? So how long will it take to have 1 milligram left in your body, right? And at this stage in the Leaving Cert, when everybody should be well prepared for this type of question, you're not substituting in the 15 milligrams, you're putting the function, or sorry, the 1 milligram, you're putting the function equal to 1. Okay, and again, there should be no real explanation there, right? That's at this stage, Leaving Cert higher level, setting up that equation should be no problem to anybody. And similarly, solving the equation should be no problem. We're trying to solve for t, so we get rid of the 15. And how do we solve an equation when the unknown is an indice or a power? Well, that's where logs comes into it. Right? And the well-prepared student will have absolutely no problem converting this from an indice equation to a logs equation, which looks like this. The base number is 0.6, so it's log in base 0.6 of 1 over 15 equals t. Now, if you're a bit uncertain about that at this point, you just need to go. That's just one of the fundamental techniques in Leaving Cert higher level maths that you need to be able to master and have no problem with that. And once you have that one done, you have that sub that into your calculator, and 5.3 is the answer. Now, this Part C then was interesting, right? Because it was an explanation you were needed. Okay, so you're asked to explain how, after the 4th injection, so on day 4, after the 4th injection, the amount of drugs in his body is represented by this expression. So how is that the case? How do you explain that? And there's 2 ways you can do it, and it was actually very easy to pick up marks in this to get 5 out of 5 in this. And this is a very simple way, right? So on the very first day, now this part here represents the first day, he injects 15 milligrams, but every day it decreases by 40%, and that's where they get 15 multiplied by 0.6 to the power of 3. Okay, and if that's all you said, actually you got full marks for that. Right? So if you said anything that was true in this case, you got your full marks. But you could keep going then, and you could say this is similar for the 2nd and the 3rd day, and the 15 on its own represents the injection on the 4th day, because that hasn't deteriorated yet. It's immediately after he's taken it, so that's your 15 milligrams. Okay, and then you could say that the reason that they're all added together is because all of these drugs are in the system at the same time, so you add them all up to get the total amount. So that would be a perfect solution for that. Now, if you look at it, it's very kind of wordy as well, right? And this is maths at the end of the day, so you could actually answer this with less English sentences. So you could say after the 4th injection, or at the start of the 4th day, his first injection is represented by 15 by 0.6 to the power 3. Second injection is this. Third injection is this, and this is his 4th injection. So without any words or any big long sentences, that was enough to get you full marks as well. As long as you made the connection between that the first injection was this, the last injection was this, that gave you full marks as well. Okay, so you can either write a big sentence anytime you're asked to explain something. You can write big sentences if you want, but if you can do it in a more mathematical way, that's fine. So now, find the total amount of the drug in Alex's body immediately after the 10th injection. Now, this was an interesting question, and the good student, right, the one who's very familiar with sequences and series, will know that this is a geometric series, right? It absolutely stands out perfectly that this is, you're adding up, it's going up with a common factor each time. So it's a geometric series formula, right, which is this. Your first term is 15, your common ratio is 0.6, it's going up in 0.6 each time, and it's 10 for the 10th injection, so your n value for n is 10. Right, when you sub that into your formula, you get your answer, which is that. Now, the frustrating thing about this question when I was correcting this is the amount of people who did it the manual way, right, who just took this sequence, or series, and kept adding it up until they got to the 10th one. Now, that was fine, right, and a lot of people did it and got the correct answer, so they got full marks. But if you made any mistake in this, right? If you said 37.17, or if you it just added up wrong, you got very little marks. I can't remember, did you get 4 marks or did you get no marks at all, right? Because you didn't use the formula. So you had to get it perfectly right if you were going to do it that manual way. And the reason that's frustrating, they could have also said how much is in his body after the 100th injection. Right, and you're like, if your only approach to answering this question is to do it the manual way, there's no way you're going to be able to do it with the 100th injection. You'd be there all day doing it. So just make sure that you acknowledge that when it's a geometric series or an arithmetic series, that you're using the formula as opposed to the manual method. Now, at first glance, this question looks as if it's a difficult question, all right? But the big giveaway here is that they tell you what to use, the sum to infinity of a geometric series formula, right? Whereas they actually could have just given this question without telling you that. They could have said, find the amount of drug in Alex's body after a long period of time. That would be kind of hard to make that link between that and using this formula, right? But they tell you this formula to use, okay? So even if I would guess that a lot of people didn't really understand why they were using this formula, but nearly everybody got this question right? So that was another 5 marks just for subbing into this formula. But basically what it means, 37.5 was your answer, okay? And what it means is that if he kept on taking the drug for technically an infinite amount of time, but if he just indefinitely kept on taking it, there would never be more than 37.5 milligrams in his system, right? So that's just the nature of infinite geometric series, that you'd imagine if he takes it for an infinite amount of time, that it would just keep going up and up and up, but it will actually never go beyond 37.5. It's limited to 37.5 milligrams. Now, this one then is completely different. Now, the big mistake that people make in this, and I mention this every time it comes up, is you're asked to show something here. We'll talk about what's happening up here now in a second, but you're asked to show this formula, right? Now, the big mistake is that people start with this and try and work with this for some reason. I don't know how they think they're going to show anything by doing that, but you don't start with what you're trying to show. This should be your final line down at the very end. Okay, so just keep that in mind. Don't fall for that trap of trying to manipulate this in some shape or form. That's going to be your final line. Now let's look at it. Now look, I kept this geometric series formula here from the previous question here, and clearly that's a geometric series, right? And this, in the information here, we can use a geometric series as well. The only difference is that instead of 15 milligrams, she gets D milligrams at the very start, and instead of decreasing by 40%, she's decreasing by 15%. So it's going to be a very similar geometric series, except it's going to look like this. Okay, so that's the key to this. And once you have this, I don't think I'd say everybody who got this bit out got the rest of it out. All right, so it was quite straightforward after that. You're using your geometric series formula. Your first term is D, your common ratio is 0.85, and N is N. All right, so we wanted to, and you can see N is in your answer as well. So sub it into your formula, and the problem was it was difficult to see how are we going to get from here to here. Right? But the good thing is that when you know what you're trying to prove, it actually makes it a small bit easier. And what happens is 1 minus 0.85 is the same as 3 over 20. This is the way I would have done it anyway. And dividing by 3 over 20 is the same as multiplying by 20 over 3. All right, so you got from here to here easily enough. Now, what other people did is they multiplied above and below the line by 20. All right, so you'd end up with 20D, and the 20 here and the 20 here would cancel. But when you know what you're trying to show, it makes it easy. The algebra a small bit easier to get from here to here. Right. So as I said, the vast majority of people who got this much ended up getting it out. But anybody who tried to start with this straight away, if that was your first line, you got 0 marks. So just watch out for that. And then part 2, very simple. So we're using this formula now to say after the 7th injection, there are 50 milligrams in our body. So find the amount of drug in one of Jessica's daily injections. All right. So again, it's actually a very simple application of this formula, but you're putting it equal to 50. So after 7 injections, it's 50 milligrams. So now we just solve now for D, and this is actually a lot easier than it looks. You can multiply across by 3, right, and just simplify all of that here, which comes out as this. And when you divide by 150, you get 11, and it's to the nearest milligram. So your answer is 11 milligrams. So also the vast majority got this right, but a lot of people skipped or just made a mess of this. Maybe might have done all the way up to E, okay, and got a good few marks out of it, but they might have made a mess of this and just didn't bother with this then, right? Whereas you could have made a mess of all of this question and still answer this one perfectly. So just watch out for that. So that's what I'm saying about this was 50 marks. And it was very, very easy to get at least 30 marks in this with just very, very basic maths.